Okay. So what we're going to be looking at, so having looked at your books, I want to go through again solving equations with you. Okay? Because a number of you were making some mistakes, and then there's one set of stuff that we haven't done yet and you really were not great at. So I'm just going to go through a few things with you. Alright, so we're going to make some notes and then you can do. Now we have sort of talked about this before. So for instance, I've been talking about this type of problem with my IB1s actually today. So if I write that on the board, is that an equation, an expression, or what? Yes?
An equation.
It's an equation.
Because it equals, so
Exactly. So this bit is on its own an expression.
Yes.
What does that expression turned into an equation actually mean?
Wait, how does it turn into an equation?
Because it's got an equals. So this is given a value, isn't it? So it has been given a value. So, what does it mean? Do you remember we started algebra with think of algebra as a language? So read that to me in English. Yes.
It means that 3x's plus 1, 7 equals 22.
Yeah. So it means 3x's plus 7, right? If I do that, I get the answer 22. So what I want to know then, if I ask you to solve this, it means find x, okay? It means find x, but I want to know what the x value was, that if I did it times 3 and then add 7, I'd get the answer 22. Okay? So I've already given you a way of doing that. So I'm going to rewrite it. 3x plus 7 equals 22. What would be your method?
Okay, so you can take away the 7 on both sides. So take away 7 from 7, take away 7 from 22.
What does that leave me with? On here, this leaves me with
0.
3x
3x
equals 50.
15.
Now, I just want to jump in here. So the language that I could be using then. If I know that 3x's add 7 makes 22, well, by taking the 7 away, I am now left with, well, just the 3x's before I added the 7 must be worth 15. Yeah, does that make sense? That's why we do it. So what do I do now? If I've got 3x's make 15, you started, so you finished, Taylor?
You divide it by 3.
So I divide it by 3. So I share the 15 between the 3x's by doing divide by 3. Well, that gives me 1x, and 15 therefore divided by 3 gives me 5. So I know 1x is equal to 5. So when we did it, I talked about a few things, not just writing. So for instance, you don't write this down, I'll do it. So I remember saying to you, let's not do this. Okay? Because do you remember how that's different? That's different because I've not kept the story going. So here I know that 3x's add 7 is 22. I then know that, well, 3x's has to equal 15, which means 1x has to equal 5. Here, I've got the 3x's add 7 is equal to 22, but I have no story then. Where does the x go? It's just disappeared. I've just said 22 minus 7 is 15. I've not communicated that very well. Does that make sense? So we get the right answer, and we are working down the page, because another way I don't want to see you do it is do this. I'm sure you remember this now.
Yeah.
I don't want to see that, because if I write that, what am I doing?
You're saying that 3x plus 7 equals 22, take away 7. Which equals 15 divided by 3 equals 5.
And it doesn't, does it? So I'm lying a couple of times. So this one I shouldn't do, this one I shouldn't do. Although this one's more, they both end up with the right answer, don't they?
But
it's
they
about-
kind of like don't tell you like how they got the answer. So if someone was trying to do that, they'd be like, how did you get?
I know. If I'm trying to mark your work and you do it always like that, it's so awkward for me to read. Even this, you might think, but that says exactly what. It's kind of easier, but it's still a bit awkward. So if I ever spot a mistake, it's harder to spot the mistake where it comes in. But if you do it like this, however you want. So for instance, an alternative would be to not put it like that, but say, well, 3x plus 7 is 22. So some people then say, instead of writing it underneath, they do 3x plus 7 minus 7 equals 22 minus 7. And then they write 3x equals 15. Yeah, it's fine. The 7 just goes... I just prefer to have it separate, that's all. But you can do it like that as well. Right? Because then the next bit is still divided by 3. So I get x equals 5. That's equally fine. Alright?
So it makes it seem more needed.
Up to you. As long as you've got a nice progression, I can see what you're doing. Alright? So what if I then said to you, solve 2 times x plus 4 equals 14. You do them all. So let's find someone else. If you know how to do it. Someone else. Tiaja, do you know how to do this one? There's a couple of ways to do it.
You can write it as 2x plus 8.
So I could expand the brackets. Alright, expand the brackets and get 2x plus 8 equals 14.
And then subtract 8 from...
So subtract 8. You notice how I'm putting it on the top this time instead of underneath. So I've got 2x equals 6. I then... Actually, another way to write it, which I'm also perfectly happy with, is if sometimes I do it like this. I say subtract 8 from that side and subtract 8 from that side. I do it like that. And then the next time I will divide by 2 and I do it like this, which gives me 1x equals 3. That's another way of doing it. But however you wish to write it, as long as you write it good communication. Right. I don't have to expand the brackets though. Would anyone do it a different way? No? See, I actually think it's easier to say this. If something add 4, then times by 2 gives me the 14. Well, why don't I divide it by 2 first? And that just leaves me with x plus 4 equals 7. And now I subtract the 4 and get x equals 3.
Oh, so technically it's like you're moving this here from up there to divide it?
No, I'm not moving anything.
No, you're just...
I'm doing the opposite of timesing by 2.
You're dividing.
So do you remember I said the whole language thing is understand what's happening in the right order. So I know in this case, I take x, then I add 4, then I times by 2, and I get the answer 14. So I have to do the opposite. So I divide by 2 first, because the dividing by 2 gets rid of the timesing by 2. So I do it on that side, which means I have to do it to the answer as well. Then I do that bit. So I don't need to expand the brackets. Yeah? So for instance, if I gave you another one,
I still want to expand the brackets.
we'll have a go without. So let's do a minus 5 equals 15. What would you do with that one?
Underneath there, that's still showing how to expand the bracket.
That's this one. It's not expanding the brackets. It's what I'm doing here. So I'm showing that that's what happens to x. So I do the opposite. So 14 divide by 2, then subtract 4, and it tells me what x must have been. Yeah? Do the opposite.
Yeah, but why did you divide by 2 at the beginning?
Because the last thing that was done, so up here, look, the first thing that was done was times by 3 and then add 7. So the first thing to undo is the add 7, so I take away 7 first, yeah? But on this one, the first thing to do was add 4. Then I times by 2, so I have to undo in the opposite order. So I can't just take away 4 here, because I've got to do the 2-bit, get rid of the times by 2-bit first. Yeah. Now if you expand the brackets, you get rid of the brackets issue. Yeah. So has anyone done this one already?
I'm figuring it out. Who did it?
So the first step is to
Divide that all. Divide 3.
divide everything by 3. Divide by 3 gives me
8 take away
minus
5
equals 5.
And then you plus 5.
then we add 5, sorry, not 4.
4.
Add 5 and I get
8 equals 10.
10. And it makes sense, because if you look at it, 10 minus 5 is 5, times 3 makes 15.
Yes.
Okay. So does that remind you how to do that sort of thing?
Yeah.
Okay. Let me try one more of this before we step it up at another level. I want to step it up another level after this. Okay. So the next one would be
Okay.
so I've got 1 plus 2x divided by 5 equals 7.
Yeah.
Now, what I want you to do is think, if I were to put an x value in myself, what would I do to work out the number, the answer? Then, change it to that answer that we've been given, which is 7, and then undo to work out what they started with. Does that make sense?
I'm confused.
So, my thought process would be, if I start with 1 plus 2x over 5, and I say, right, if x equals 2, for instance, what would I do to give this a value? So I would take x and do what?
Take it away. Wait.
So how would I give this a value? So equals what when x is 2? Well,
X times 2.
So I would do times by 2 first, then I would add 1, then I would
Divide by 5.
what?
Divide.
Divide it by 5, and I would get my answer. Yeah, which in this case would be, so
Wait, can you do it in the
2 times 2 is
4.
4, 4 add 1 is 5, 5 divided by 5 is
1.
1. So if I were to put x as 2, this would equal 1. Alright? So that's what I would do. So what I do now I've understood what I would do, I've got to do the opposite. So this time I'm starting at 7 and I've got to figure out what we put in. So what do I have to undo first? So I have to times it by 5, and what answer do I get?
35.
35.
Plus 8.
Then I have to minus the 1, which means I get 34, and then I have to divide by 2, which gives me 17. Okay.
What?
Mom, get your hair off my desk.
Oh, okay.
Okay. Now that's what I'm thinking of it. That's how I'm thinking. How would I do it algebraically is important. How would I do it without having to do all of that? So, now remember, this is what I'm thinking. I'm timesing by 5, minusing 1, dividing by 2. So, how would I write it in a slightly different way? So, what's the first thing? We have to times by 5. So I do 5 times all of that,
Which is just 1 plus 2.
which leaves me with 1 plus 2x. Alright?
What?
So if I times by 5, that gets rid of the divide by 5, yeah? But I've got to do it to the other side, because obviously the answer now is 5 times bigger. So I've got 1 plus 2x has to equal 35, which is what I had. Yeah? Does that make sense? I want to make the link. So this is what's going on in your head. Alright? That's what you're thinking. And this is what we're writing. That make sense? So, I know I'm thinking this is what I've got to do. This is the order in which I'm doing it. Obviously I have written that, but this is what I will do in my head from now on. So I times by 5 first to get rid of the divide by 5. That makes sense? So 5 times to get rid of the divide by 5. So that's this bit. Right, and have to do the same to the other side. What do I do now? So I've got 1 plus 2x. Well, again, I read that as, well, I have to take x times by 2, then I add 1. So I have to subtract the 1. So I'm going to subtract the 1 from both sides, and that leaves me with 2x equals 34. So that bit is like this bit. So we've got the minus 1. So I've done that. And then we've got to do the final bit, which in my head is divide by 2. So we've got to do divide by 2, which gives me 1x equals 17. So that's the divide by 2 bit.
I'm confused.
Which bit?
Everything.
No, you're not. You know how to do it. Which bit are you struggling with? It's not everything. You can't say everything.
Wait, so for the writing bit, so you just times it on both sides?
Yeah. Because obviously, what you've got to think about it is that if I do something to the problem, I'll change the answer, won't I? Yeah. So I have to do it to both sides. Right. So on this side, look. This is divided by 5. So if I undo the divide by 5 by timesing it by 5, the answer will also have to be 5 times bigger, won't it? So that's why I did it on that side.
Okay.
Yeah. Does that make sense? Do you want to have another go, a different one?
Sure.
Alright, before we move on to the next thing. So, let me give you 2x plus 11 all divided by 3 equals 0. Have a go at that. Okay, so I've just written a little thing here. In my head, I'm looking at it saying, what does it say? So it says that I take x and I do what to it? First.
We times it by 2.
Times it by 2 first, then I add 11, then I divide by 3, and I get the answer 0. So I've got to think that through. First thing we do before I start. Then I know how to do the opposite. So I've then got to think, right, I've got to do the opposite of that. So if it's x times 2 add 11, then divide by 3, what's the first thing I have to undo?
3.
The divide by 3 bit. And what's the opposite of dividing by 3? So I've got to undo the divide by 3, so I
times by 3.
times by 3. So if I do 3 times all of that,
It would be 0 times 3 at the end.
so this would also be times 3. So this gets rid of that.
No. And then it would be 2x plus 11 equals 0.
Good. Some people would put 3 there, I think. 0 times 3 being 3, but we know it's 0 still.
Wait, and then you take away 11 on.
So now we're at the stage of, well, this time I know what the answer is before I divide by 3. Now I've got to figure out the answer before I add 11. So I have to take away the 11. So I'm then, that cancels this bit out. That's now not there anymore. So I'm left with 2x equals
Negative 11.
negative 11. And now, alright, now I have to undo the times by 2, which is this bit. So I do divide by 2. And then I just need to say, well, a negative 11 split into 2 parts is negative 5.5.
What?
Yeah.
I get it now.
Get it? 5.5 is also negative 5 and 1/2. Right. How'd you feel about that? Easy, right. Let me ask you then, let's take it up a step. But we're using the same methods. So, we're going to now look at, if I asked you to solve 6 add 2x, read that to me, what does it say?
What could they possibly be doing?
Shh. What does it say?
6 plus 2 times
X times 2.
So what do? I think of it as x times 2, then add 6, yeah? Because I can add in any order. That is equal to, alright, this time not a value, but equal to 15 subtract the same x. Yeah?
Wait, 15. Wait, where's 15?
It's just, I've written the question. That's your question.
Oh,
We've
how are
got
we
to
doing
solve that now. So we use the same process, same idea. So we say that, well, if 6 add 2 x's is the same as 15 take away an x, well, if I add x to both sides, so I want to add an x to that one, because that gets rid of it, right?
Yeah.
And that leaves me with just the 15. But I've got to do the same to the other side. So I add the x to the like term, so I've got add an x, so I end up with 6 plus 3x, alright? So what I've done is I've undone the fact that they subtracted x from one side, so I've made both sides 1x bigger. And it's still equal, isn't it? If I add the same thing to both sides, whatever it is, the equal sign is what's important. Now I'm in exactly the same place I was before. What do we do now?
Take away, take away 6.
So take away the 6. That gives me 3x's equals 9.
Divide that by 3.
Divide that by 3 and we get 1x equals 3. Make sense?
Yep.
Right, one for you then. All of you. 9x minus 11 has the same value as 15x's add 4.
Thank you.
You right with that? Have a go. 9x's take away 11 has the same value as 15x's add 4. Tell me what you think we could do first. Haji.
Okay, so would you take away x on both sides?
Alright, so if I take away x, what am I left with?
8x.
8x, and you still have the.
Oh.
Exactly. That's really good. I'm glad you said that. If I take away x from both sides, I am not left with 9 minus 11, am I?
So you take away.
What would I be left with?
8x.
8x's minus 11 equals 14x's plus 4. So I've taken away an x. So I don't want to take away 1x. What do I want to take away?
9x's.
9x's. Let's take away 9x's instead. So take away 9x's from both sides, because now what does that do?
This gives you x.
So it leaves me with 9x is gone, they're gone. So minus 11 and 6x's is plus 4. Does that make sense? So I had 9x's on one side and 15x's. Now remember, I'm just trying to keep it so it's the same on both sides. So if I take 9x's away from both sides, it's all still equal, it's the same value. So 9x's minus 11 has the same value as 15x's plus 4. So if I take away 9 from both sides, I know I'm left with, well, minus 11 has to equal 6x's plus 4. Make sense? That's the logic. What do I do now?
Take away.
Can't take away 11. Take away
I can take away 11. It wouldn't help me.
Can you take
But I
away
can take away 4. Let's take away 4. So I'm left with just 6x's on that side. What am I left with, guys, on this side? Good. That's why you need to know your adding and subtracting negative numbers.
That's easy.
Doesn't stop you getting it wrong.
And then you add 15 on either side now.
Oh, no, I don't.
You take away.
You divide by
Wait.
6.
Divide by 6.
Well, what's 15? Negative 15 divided by 6. Well, 15 divided by 6.
So if I have a calculator, I'm fine. If I don't have a calculator, do you know how to do your equivalent fractions? No. So both of them can be divided by 3. So I'm left with negative 5 over 2. Now by doing that, I've now made it easy to do as a decimal, haven't I, as well? So x would be negative. Do you know what 5 divided by 2 is? 2.5. But this one, I would say leave it like that. We don't need to do the decimal. Make sense? Okay. So we're going to have to do a lot more of this anyway next lesson, but I'm going to ask one more type of question. Extend it one more time. 2. Solve. Okay. I'm going to get you to solve x squared plus 2 equals 51. So this time it's not a 2x, it's an x squared.
X times an X.
So it's an x times an x. So if I was to think about it again, x times itself, then add 2, gives me 51. So what's the first step?
Isn't divide x.
Not yet, no. I've got to minus the 2 first. Because if you remember what I said, think about it. X times x gives me an answer. Then I add 2 and I get 51. So I take away the 2 and I get
49.
x times x equals 49. Now, how do I do
No, but
The opposite of something times itself.
Square root.
Square root. So I have to do the opposite of squaring. So I square root both sides.
Oh, so 4 to 7.
I think just, are you going to give me, hopefully you give me the full answer. So x squared square rooted is just the x, because these two things cancel each other out. So this square root cancels that squared. So please give me the entire answer. What's the square root of 49?
X equals 7.
X equals 7.
X equals 7.
7 because
And
Negative 7.
negative 7.
oh, we had this in one of our calls.
You did, yeah.
Wait, but why is it at -7?
The reason is when we have, what's this? This is called, by the way, this is called a quadratic. Okay, it's a quadratic. Now, when we have a squared, when you multiply a number by itself, if it's a negative, it becomes positive. So if you think about it, put x in, square it, then add 2. Now if I put 7 in and do 7 squared, or I put negative 7 in and do negative 7 squared, both of them give me the answer
Oh.
49.
Oh, that's why.
Then I add the 2 and get 51. So I've got to give both roots through to give the full answer. All right. That was in that exercise, yeah? Do you remember seeing it? It confused people. So we'll do more of all of these. So, homework. Not official homework. You've got, well, the Padlet's kind of needs to be ongoing. But I would like, if you think I know how to do everything we've just done, no problem, no homework. Maybe have a go at a couple practice, up to you. If you think, actually, I need extra time thinking about that, I want you to watch the video.
Okay.
And practice and just check, so that when you come back, you can just get on with some. Alright? So I don't want you to come next lesson on it, I have no idea what I'm doing. Make sense? Take that as a yes. Cool. Have a good evening.
You too. That's